Yeah, hello, Mark. Simon here. Sorry to bother you. I'm completely baffled. I've been trying very hard on this, but I'm just a humble biochemist, and I'm lost on some of this genetics. This is the whole genome for um, HAR1F, which contains the HAR1A sequence that Ella and I have been concentrating on. So this is about 2,800 and something NTs. I've converted thymine to uridine for this one. If I just copy that, I'm using something called BLAT, which has been recommended to try, and the result's quite interesting. So looking for chimp, but I'm not quite sure what I've actually got, to be honest. So submit that. There's a sequence there with a 95.7% match on chromosome 20 with those locators. That's a bit of a surprise. I don't quite know why it's so much higher. So if I go to details, this is your sequence, i.e. the original human sequence. If I go to chimp 20, it does look as though it's the same sequence, but there's a few confusing sections. I don't quite know why some of the nucleotides are written in lowercase. There's quite a lot of them in some places. Uppercase in blue colouring are matches, definite matches, but these are definite matches as well, so I don't quite know what that means. And if I scroll down, this very large section here, which is almost exclusively guanine, I don't know what that means either. I really don't know what that's doing in there. So if I go down to, I don't know if you can see this on the left hand side, the side-by-side alignment, I do more or less understand this. Obviously it's self-explanatory, and I would guess that mutations are marked like that with the bar missing. I don't quite know why there's spaces here. Presumably that means that there's been a deletion, and chimp has got thymine and adenine there. I keep going down. This is something I'm going to come back to at the meeting because this area is quite intriguing, and I suspect HAR1A is around about 851, something like that. I seem to remember 861, something like that. Which I've just scrolled past, haven't I? Which is in this area here. And if you look, the characterization of HAR1A is an unexpectedly high number of mutations, all C to G or A to Gs, which is exactly what we've got here. So I think this is another factor indicator this is in fact HAR1A for chimp. I really hope it is. I'll check these numbers later against the official version of HAR1A for Pan, but I'm pretty sure that's why all those mutations are in there. Because if we scroll down, the mutation rate is more or less what you would expect. Not much at all happening there. And the only thing I'm left to query is that some of the polyadenine tail seems to be missing from both of them, which I don't quite understand why there's bits missing there. So there are a few queries there, and when you have a couple of minutes, I would appreciate your comments. And I haven't copied anybody else into this yet because I think you you may be the person that would understand this best out of everybody. So I look forward to your help, and yeah, I still owe you bottles of Plonk anyway. It's going to be a crate load by now, isn't it, really? Thanks, Mark. Bye now. Bye.